Hi, good afternoon. So yes, I'm a solutions architect at Amazon, and I want to talk to you a little about security before I introduce Trend. So the key thing with security on AWS is that it's a shared responsibility model. At AWS, we're responsible for the data center security, the security of your physical servers, the physical network, the security of storage devices, and the secure disposal of those. But what you build on the platform, the servers you run, the operating systems, that's your responsibility. So for our part, we're FIPS 140.02 compliant, we're SOX 1 and 2 compliant, we're PCI compliant, and recently in Singapore we achieved the MTSC, multi-tier cloud security compliance. We're the first global cloud provider to achieve level 3 compliance. That's the Singapore government compliance standard, so we're very proud of that. But for your part, for securing your operating systems and your applications, we have a number of partners that we can help you with that. I'm very pleased to say that since 2012, we've had Trend Micro as an advanced technology partner. And to tell you about that today, I've got Sasha here. Sasha.
Geez, I'm pumped. Look at the crowd in this room. This is absolutely amazing. I mean, there was a 50% chance that it's either that room or this room, so it's good to see that there are people in this room that are keen to learn a little bit about security, and I'm here to talk to you about a topic that's quite dear to my heart. I've been working in the cloud and data center security space now for many, many years, and AWS by far is leading the pack in the cloud space, cloud computing space. We're a proud partner, a technical alliance partner with AWS, and we've done a lot of work with the guys over the years. My name is Sasha Pavlovic. I'm the Director of Cloud and Data Center Security for Trend Micro in the APAC region. And the topic of today's discussion, if the cameraman just steps to the side a bit, is using security to build with confidence in AWS. So I'm going to first frame the scene here, just so you guys understand some of the talks that we've been having alongside AWS over the years. Some of the major events, we've done a lot of events with the guys, but these are just some of the major events that I'd like to highlight. Back in 2012, we kicked off with the shared responsibility model. Quite a simple operational model, a very, very important model to understand if you are looking to build with AWS. Are there any security people in the room? Wow, okay, one. I'm sure there are more, but that's fine. We're going to recap some of the shared responsibility model stuff in a moment. As we started to progress through the years, we started to get a little bit more tactical and a little bit more tactical. Tactical and talking about things like assisting customers and partners with achieving security and compliance when moving to the cloud, and also really kind of maximizing your whole cloud experience through the use of, and I'm going to use a buzzword here, the whole DevOps culture, automation. We love to be able to automate anything and everything in the cloud. Why? Because AWS allow us to do that. They have an API for essentially every single service in their product catalog, which is amazing. And this is something that is a new paradigm for most third-party vendors like Trend Micro and other vendors in this space. So a quick recap of the shared responsibility model. Like I said before, it's a simple operational model. On the left-hand side of the playing field here, we have the responsibilities that AWS will hand on heart look after. So we look at things like physical security of their data centers. We look at, the physical locations, physical security elements associated with their data centers, the monitoring of the data centers with security guards patrolling them and so forth. Infrastructure, that includes things like power, cooling, rack space and so forth. Again, these are things that you as a customer, we as customers, don't need to worry about because AWS have this covered for us. Networking, so protecting the assets that AWS have spent so much time and effort in building. Perimeter-based defenses, firewalls, network intrusion detection prevention capabilities and so forth. These are all things, again, that AWS provide as part of their shared responsibility model. And virtualization. Now, this is actually a really good one to bring up because virtualization here, last year there were two critical bugs that were identified in the Xen hypervisor. And AWS went through the notions of patching these hypervisors with almost zero downtime to their customers globally. Now that's a huge feat. That's fantastic because, again, there is zero downtime to us. We're looking to AWS to really kind of maintain as much uptime for us as possible, and by doing things like that, patching on the fly with zero downtime is a brilliant thing. So, hats off to the AWS team. And on the right-hand side of the playing field, this is where you as the customer, this is where you guys have a responsibility to ensure that you've got the appropriate security controls in place for these various different elements. So operating system is probably the key there. So EC2, I'm sure that everyone's used EC2 at some point. Anything that you decide to launch on the AWS platform, whether that be a Linux instance, whether that be a Windows instance, you have the requirement to ensure that you maintain regularity around your patch cycles. So your security patches, you make sure that you're constantly up to date with those. That you have the appropriate security controls, so things like malicious content scanning, intrusion detection and prevention capabilities, file integrity monitoring, system integrity monitoring. These are all requirements that you as the customer are onboarding as part of the shared responsibility model. Same thing with applications, Same thing applies. So ensuring that you've got the appropriate security controls in place, patches in place to safeguard your applications, to protect your applications that you're serving to your customers out there. Data. We talk about data. There's a variety of things that we can throw into the mix here: data sovereignty, Patriots Acts, and all this other wonderful stuff. But the bottom line is that the integrity of your data is on your behalf. So if you require technologies like encryption, this is something where you can look to utilize native technologies that AWS provide as part of the service catalog, or even third-party technologies to encrypt your data, manage your keys, and then handle that whole data encryption process that way. Last but not least, service configuration, and I really want to highlight this one here because service configuration is where I tend to find most people make mistakes. If you're looking to build technologies, build networks inside AWS, you need to make sure that you understand what it is that you're working with. And when we look at things like identity access management, security groups, VPC network configurations, these are all things that, again, if you're not quite familiar with those services, take the time to do the training. AWS have some phenomenal training courses. Do the training to understand these services top to toe, because they are absolutely paramount to ensuring that you've got the most secure environment as you're going ahead with your AWS experience. But as security professionals, we are all paranoid people, right? That's where that whole tinfoil hat thing comes from. We are a paranoid bunch, so we want to be able to verify this. And in order to verify that AWS are keeping up their end of the bargain, we can do that quite easily because they've made it easy for us. aws.amazon.com/security, this website here has a great deal of information around all of the security compliance requirements and everything else that's associated with this left-hand side. They've got information about. So, if you're having trouble sleeping, you can basically request SOC 1 and 2 reports, have a good read of that, and I'll guarantee you that you will fall asleep. But hey, if you are in compliance and security, it may be of interest to you. The bottom line is that this information is readily available at the click of a button, which is fantastic. So Trend Micro, we're a security provider. We've been in the game for 27 plus years. What we're going to do today is we're going to frame a real life situation. We're going to split this into 3 distinct areas: a vulnerability, the response process, and also the repair process. Before I go on, just a quick show of hands. Who here has heard of the bash shell? And don't be shy, please put your hands up because I'll be worried if not everyone in this room puts their hands up. Fantastic. So the bash shell is a piece of software that's been around for a very, very long time. Anyone that uses a Linux distribution today, in most cases you'll be running bash with your terminal. Anyone that's using a Mac OS X flavor of operating system here, again, the default shell is also bash. With that, has anyone heard of the shell shock vulnerability? Not as many hands as those that have heard of the bash shell, right? Which is quite interesting, and that tends to be consistent across the summits that we've done through the US and the ANZ region. So shell shock has been ranked or rated as the vulnerability of, I believe it was the century is what they said. It was rated 10 out of 10 by the National Vulnerability Database, 10 being so easy to exploit, and 10 also being so widespread and critical in nature. I wouldn't normally show attack code in this type of forum, but this is just how simple and easy it was to exploit the bash vulnerability or the shell shock vulnerability. What we've got here is we've got some code, just a few commands on the left-hand side, and then we're using a pipe command to then concatenate whatever additional syntax you want to include. So, I mean, what this is emulating here is this emulates an attack that's sitting in front of your machine, in front of your workload, in front of your instance, that's punching in commands and pulling data out of your system, right? This is how easy it really was to exploit this vulnerability. And let's actually I'd like to show this. I've got a little demonstration here. We've got a very simple website. There's not much to it. It's called Mark's Marvelous Marketplace. It's a contacts page. A couple of areas in here that we can look to manipulate. But ultimately, as the attacker, what we're looking to do is we want to view the page source code of this website, and we're looking for certain elements on this page. Here we go. All right, so right-click, view source code. You'll see here that the browser will magically display this information. What we're looking for is this particular line here, showing us that it's using CGI, the Computer Gateway Interface. For those that don't know what CGI is, it's essentially the interface between your end user or the person that's running the web browser session, and then ultimately it takes it to the back end, it crunches it on the web server, and then presents the results back to the end user. So let's put our black hats on. What we're doing here is we're running a command line web browser called curl. We're going to input some code here, we're going to input some exploit code here, and what we've done here is we've actually requested the password file from that web server. Now this doesn't really give us much information, but again, very simple to do. Let's get sinister now. What we're going to do is we're going to inspect the Apache config file, and we're going to look for the physical location of where our private keys are stored for our SSL certs. We found them. Next thing we do is we pull them. All of a sudden now, I have your private key. Now you can imagine this was done from a user that's sitting on the other side of the world. Your website happens to have been vulnerable, or your web server happens to have been vulnerable to this exploit. And now we've got your private key. So what this allows an attacker to do is take this private key and set themselves up in between your end user and your web application or your web server. So now we can intercept your data, we can decrypt that information, we can look at it all in plain text, re-encrypt that, and then pass that back along to the web server completely unknown to both parties. It's a pretty scary thought. But we're going to get even more sinister in a second. Before we do, a quick history lesson. Does anyone know when the bash shell was first introduced? And again, don't be shy. Please put your hand up if you know the answer to this. There is a $100 marketplace voucher in my pocket for anyone, that AWS marketplace voucher in my pocket. Anyone? No? All right, fine. 1989 was when this piece of software was first introduced. So 26 years we've had bash living on our mainstream operating systems, our Linux systems, our Mac systems. This piece of software has been in circulation and still widely used for the last 26 years. What else was released in 1989? This amazing piece of technology right here. What this thing did was just completely mind-blowing. You punch numbers in and you make phone calls, right? And it weighed in at a whopping 12.3 ounces. Metric terms, about 350 grams. So what we can do is we can take a stack of iPhones with all their feature-rich capability, and it still wouldn't stack up to the weight of this thing. Now, the point of this is you have a look at the evolution of technology, of the technology industry in the last few decades, and we've gone from this brick to our iPhones and our Androids and all these phenomenal pieces of technology that we can do just so much with. And yet we have a look at something like bash, which really hasn't changed in the last 26 years. So it was first introduced in August of 1989, and it was released to public about a month later. It took 9,141 days for us to realize, hey, hold on a second, there's a problem, and it's a pretty damn big problem at that. It's a world record. So over the course of about 2 weeks, there was about 5 security patches that were released to fix this vulnerability. So during this period here, IT admin folk and security ops folk were sleepless nights. Everyone was afraid and scared. Emergency patching schedules were just constantly rolling over this period to make sure that we were protected. But again, it was a 2-week period there of exposure. So if we collapse that into a slightly more easier to read list there, we've only got 4 here that we've listed, but there is a 5th one there. But you're looking at 4 days is when the first, 2 days is when the first patch was released after the vulnerability was identified. 9 days beyond that, the second patch. 4 days beyond that, the third. A day beyond that, the fourth, and 2 days beyond that, the 5th. Right? So let's have a look at the respond process now. We know that there's a problem. How do we respond to this issue? Because now we are hosting our web applications, our web servers in AWS. We know that our web servers are now vulnerable. What do we now need to do in order to respond or apply a band-aid to this whole situation? What this is here is this is a reference diagram, fairly simple one, and one of many that are available on the aws.amazon.com/architecture page. Now, this is a very simple reference diagram. It talks about how to build a web application hosting network or service inside the AWS cloud. And what we're going to do is we're going to focus on just the core elements here that affect us as the users and our the security folk. We want to make sure that we've got these elements covered. So we've got 4 tiers here. We've got a load balancer tier. We have a web server tier, we have another load balancer tier, and the 4th tier is our web application or our application servers that might be running our back-end system or our databases or whatever that may be. So if we flatten that to a 2-dimensional diagram, this is what it essentially looks like, right? It's pretty straightforward, and I'm sure that most folk in here have seen this and think, well, that's pretty simple. And it is, excuse me. So the load balancer right up the front there is accepting traffic on port 443. Now, what comes in on port 443? HTTPS. We assume that it's HTTPS. And I'm going to highlight that word for you because we're going to come back to it. So I actually had a video here, but due to time constraints, I've had to cut it out, but I'm going to step you through it. Essentially, the idea is that we have to go through a few phases to ensure that we've got the appropriate security in place. So the very first thing is that service configuration thing that I spoke about earlier. We need to make sure that we've got the most appropriate, best practice, hardened service configuration as possible. So we're going to start with our identity access management roles. All right? So our web servers will have roles associated with them. We want to make sure that the permissions that are attached to those roles aren't doing anything funky or over and above what they should be doing. So again, checking the roles, very important. Now, if anyone that's done, essentially launched machines with roles in AWS, you'll note that you can only attach a role once to a machine. Once it launches, once it gets instantiated, that role is then attached forever, essentially. Policies can then apply to that role, but it's important that we get that right to begin with. The second thing is security groups. Security groups are an extremely powerful feature that AWS provide us with. So it's logical separation of our EC2 instances. It's essentially a firewall, but we can logically group our machines based on the security groups as opposed to CEDAR blocks or IP ranges, which is a really powerful feature that they offer. So ensuring that we've got the appropriate security group configuration is paramount. Network segmentation, if you have multiple subnets that you're working with, we need to make sure that we have the appropriate routing tables in place, right? Public subnets should be public, private subnets should be private. So any private subnets should not be essentially connected to an internet gateway service, right? There should be sync-hold to a single network interface, which might be your NAT box or something along those lines. And also finally, NACLs. Now, the important thing here is that AWS actually offer this as a checklist. It's a horribly named document, sorry guys, but auditing security checklist for use of AWS. But it's your best friend if you are looking to architect and design and deploy infrastructure in the AWS field. This is your best friend because this has a whole list of a whole checklist, I should say, of best practices that you need to ensure that you've got this covered, and then once you've got that covered, then you're pretty much safe from the service configuration end. Okay, back to our network design. The next step that we now need to do is service configuration's done. We're happy with that. We're happy that we've hardened our service configuration. Now we need to look to implement some kind of a scanning technology or a deep packet inspection type of technology. So in this example here, what we're going to do is we're going to look to deploy Trend Micro's IPS solution on each and every one of our vulnerable hosts. And what an IPS does is it essentially looks at the traffic and it basically monitors the traffic to determine whether or not the traffic that is actually reaching our workloads is in fact correct, the right traffic, the traffic we're expecting, and if it's not, we want to drop that traffic and get rid of it. So in this example here, we've got HTTPS, right? That's fine, we are expecting HTTPS to come through on port 443, so let's let that through. Second packet, HTTPS, same thing, we're happy with that, let's let it through. The third packet that comes through is SSH on port 443, right? We're not expecting that to come through. We're not expecting SSH to establish connections on 443. So this violates our policy. We're going to drop that packet and reset that connection. The next packet that comes through looks like a HTTPS packet, but through some analysis and deep packet inspection, we've identified that there's some malicious code embedded in that packet there. It's what we call SQL injection, and that's something that an attacker is is essentially launching against my website to try and extract information that they shouldn't normally get their hands on. So an IPS or a deep packet inspection engine, an IPS solution, should be able to identify that level of granularity, and then again, if we found this violates our policy, drop the packet and reset the connection. So now what we've done is we've gone ahead, we've hardened our service configuration, we've deployed a compensating control or an IPS technology on each and every one of our vulnerable hosts. So our black hat's back on. Actually, no, before we put the black hats back on, let's put the white hat on and show you how we actually did this in the Trend Micro console. So this is the Trend Micro solution here. It's called Deep Security. We've got our workload here, one of our workloads that is vulnerable to that particular exploit. So in the configuration panel here, we're going to enter the intrusion prevention section, and we're going to select the rule which is the bash remote code execution vulnerability. Now what this rule does is that this looks at all that traffic and it will identify that vulnerability or that exploit in all its various different permutations. So we're going to apply this rule here, save that away, and then that policy is going to update our instance that lives in the AWS cloud with that particular rule set. So now the black hats come on, and what we're going to do is we're going to try and exploit that machine again. And we're going to try and pull that private key from that machine. Now you see here what's happened is we've rerun that same command, and then there's an empty reply from server. We're going to rerun it again just to be certain, and again the server has dropped that connection. Now this is IPS in action here. This is the IPS system saying, hold on a sec, there is an exploit that's attempting to run on this machine. We don't want to allow this to occur, so let's drop those packets and reset that connection. Pretty simple control, but very, very effective. Now we're safe. Quick recap. So all instances are covered with our IPS control. Workload appropriate rules, very important in today's world. The cloud is so dynamic in nature. We've got various different types of instances, various different types of workloads that are launching, different applications, different configurations. So we need to ensure that our policies are contextually aware, policies that are built and appropriately built for each and every workload type. And most importantly, again, centralized management of this, because as we start to ramp up and build out our security posture, including additional services and additional modules, we want to be able to centrally manage all this stuff rather than having various different consoles to manage. So the Band-Aid has been applied, now let's look towards a long-term repair. Once again, here's our infrastructure. We've got our IPS shields up. Now, best practice stipulates, certainly in production type environments and certainly in the cloud, that you would have purpose-built, pre-configured instances or AMI images with all of your components, all your applications and configurations applied. And then we look to bake those images and then use them at a later stage, if necessary, to then stand up additional environments. That's the way we do it. We wouldn't normally do this on the fly and manage various different or multiple different AMI types. We'd bake our AMI and then we'd start to roll that out in various different areas. So how that looks in this example is, here's our AMI. This is our AMI that we use to build out our production environment. Now, we're going to call this the blue group because these instances here are, they're still online, they're still in production. However, now they're being protected by IPS, but they still haven't officially been patched yet. So the next step here is what we're going to do is we're going to create an isolated staging area. And we're going to use that same AMI to then dump it into a testbed area. We're going to launch that AMI. Now we're going to go through the official patching process where we then deploy all 5 of those security patches to fix that shell shock vulnerability. Once we've done that, we're then going to bake that AMI again, and we're going to call this AMI v2. Now, as part of this entire process, we need to ensure that we thoroughly test this new AMI, not so much from a security standpoint, although that's very important, but we want to make sure that our applications haven't broken in any way. So we're going to throw everything at this AMI, including the kitchen sink, and then, lo and behold, it's passed. That's the expected result. That's what we want. And as a result of that, now we're going to promote that version 2 AMI into our production VPC. We're now going to call this the green group. And anyone that's done this kind of work before, it essentially is the blue-green or the green-blue deployment model. So now we have 2 sets of production machines, one that's AMI v1, v2 running in our production zone. What we want to start doing is bleeding away the traffic from our blue group and then start pushing that through to our green group. How we do that is we use an elastic load balancer to do that. Over a period of time, as the connections start to bleed out and then move into the green group, we then completely shut down our blue group or destroy those machines. Now we have a fully patched operational environment. There are 2 takeaways from what I've just shown you here. Number 1, we did all this patching on the fly. Fully automated. I love automation. But we did all this patching on the fly. Number 2 is that we had 0 downtime, which is extremely important for those customers in the room that are looking to, that are either currently doing this or looking to host applications for your customers in the AWS space. It's important to understand how to do this and really minimize downtime or the end user experience. So they're the 2 key takeaways from this deployment model. So now we're convinced that, okay, we have a production zone, production environment that's now fully patched. We have our IPS security controls that are still in place protecting our machines. Although we like to think that we know what our production systems look like, the fact of the matter is that things still do slip through the cracks on the occasions, right? We can go through best efforts to deploy as many security controls as we like to do, but the fact remains that at some point something will slip through the cracks. Things do change. Some things that are expected, other things that are not expected. So one of the utilities that I highly recommend in that case for really improving your security posture is looking at things like integrity monitoring. Now, this is a compensating control again, but what this does is that this monitors the state of the system and it looks for changes that are happening. Now, some changes, as I said, may be expected, but others may not be. And this is where, once those unexpected changes take effect, the administrator needs to know about that. And I'll show you a working example of that. So back in the Trend Micro console, we're going to have a look at the integrity monitoring section, and we're going to apply the monitor SSH key material rule set. Black hat's back on. We're going to exploit this machine again. And what we're looking for is the SSH authorized key file, which we've found. Not hard to find. It's all pretty much lives in the same location on all machines. Now what I'm going to do is I'm going to replace that SSH key file, authorized key file, with my own. All right? If anyone's following why that's bad, is because now I own your system. I've replaced your SSH key file. You can no longer log into your system. Now I own that system, and I can do whatever I want with that system. I can look to use it as part of a bot network or use it to do malicious things. Whatever it may be, you've now lost full control. Now, the important thing to note is that production systems, we don't always log into production systems. So we need to, or the administrators need to understand when these things happen. Now, there's a good chance that the admin may not come across this change for some time. This is where integrity monitoring really helps, because what we've done here is we've raised an alert, and you can see on the events page that it's popped up with an event to say, hey, your SSH key material has changed. If we double-click the event, we can drill down even further and identify exactly what's happened. So the level of insight, that granular visibility is fantastic. Really good use case for integrity monitoring. So, recapping quickly, the respond process, we reviewed the configuration, we applied intrusion prevention controls as part of the respond process, and as part of the repair process, we patched the vulnerability, we baked a new AMI, and we leveraged integrity monitoring as a part of our improvement to our security posture. Guys, the important thing to note is that automation is absolutely key, because we can automate everything in AWS, right? It's a beautiful service catalog. Third-party vendors, security tools, all need to be able to fit this automation paradigm. And if they don't, it's probably time that you start looking for another solution. With that, I know we're running short on time, but I would like to introduce, just for a couple of minutes, Paul Hidalgo from MatchMove, who's here to talk about some of his experiences within AWS and Trend Micro combined. Paul?
I know there's going to be lunch, so I have to fast. All right, MatchMove. What's MatchMove? MatchMove is a startup based in Singapore. We were founded in 2009. And we're doing platforms as a service. We're a platform as a service provider for games before, but now we have this product called the MatchMove Wallet. Now, MatchMove Wallet is an online mobile payment solution. If you can see, it's a card. It's a online prepaid debit card. That's what is in the screen now. So you're gonna say, what's in MatchMove Wallet? MatchMove Wallet allows secure payments, and it's accepted everywhere. If a site accepts MasterCard, Visa, American Express, this is accepted. It's good for small and micro transactions. Think about your children, they want to play iTunes. You don't want them to use up all your credit card number, so you don't have to have a bill shock in the end. There's no age limit. So look at other countries where there's children, young people who wanted to play games, pay for the games, they can use this wallet. There's no minimum income. And there's no risk of overspending because it's prepaid, so you don't have to have overspending. For companies, there is loyalty, there are deals, and there's remittance. So if a company wants to have loyalty system across their product, they can use MatchMove Wallet. I'll go through you very quick on our product. So it takes 3 minutes to sign up. You can view your card. It's a prepaid card. You can see the card number there. You can use it online. It's very easy to top up. You can view your transactions as soon as you buy them. It's very easy to use, notifications, and then it's got promotions inside. One good feature is it has dynamic CVC. So in your card, there's a CVC there, and that thing is dynamic. So you don't have to risk like other companies using your card. You can spend, it's basically securing your money. Now, we have this model. We sell this to our partners across the region. It's B2B. So we allow them to brand it in such a way, to use their brand in such a way so they can use it for customers. So you can put, if you have a partnership with Visa, MasterCard, or American Express, you can put it there with your brand. So, it's very fast. What I can do is if you want to try it out, we'll give $5 to the first 50 signups in this event. So you can just scan this QR code. It will be on our slides later, so you can just scan, and then you can get the URL sign up. We'll pass you $5 in your wallet. So free $5. You can use this to pay for your Amazon bills. So let's talk about our journey. So we are a startup, right? And we have challenges. People are asking us, we don't have industry credibility for fintech. We're a new company. You need to have that. We need to be scalable, and we need to be world-class. So even also cost. Startups really need to save cost. And we need to be able to deploy fast, and we need to be able to innovate quickly. So what we did all cloud. Let's go to AWS from day one because we're experienced in it, so let's go for it. Another thing is PCI DSS. Now, some of you might know, PCI DSS is it's a standard where the payment card industry uses to their vendors, to the people they work with, to make sure that data is secure on these partners. Our security must be automated, and it must be modular, because you can see we allow people to brand this for their company branding purposes. So, ecosystem. Our ecosystem, MatchMove Wallet talks to processors, payment providers. We also talk to regulatory and compliance peoples, and we work with banks. So those are the key components, and these are the people who we work with. I have 1 minute to go. So how we design this, we have to make sure that our data does not leak. So that's one of the biggest things in cloud. Your data should stay inside infrastructure. So we made sure that our instances is inside a VPC. Our instances does not have a public IP. All of them have private IPs, except of course the load balancers. That's how you'll be able to visit our site. And then, of course, what we need to do is we need to have our instances get the latest updates. So we don't have a big team to do the patching themselves, so we want it automated. And then new configurations, new threats, we want them automated. And we need some kind of security logging so that we know where the attacks are coming from and when they happen. How did we implement deep security? So this is how we implemented deep security. We have an instance that is called the Deep Security Master. This is where we install the deep security server to manage all the agents, our instances. Because our instances are private, they cannot actually download the patches straight from the Trend Micro server. So they have to have a master to send it to them. Because of this, Trend Micro Deep Security helped us with 33 out of 200 PCI DSS requirements. We just have our requirement certificate a few months ago. Not only that, what we do is we also monitor our source code. So if our source code are having changes, if we have configuration files that changed, and it also checks logs for us. If people log in, if they have 500 errors, or if they're having memory issues. One thing that's good about our setup is we can use an automated scanning tool. So every week we run a AV scan, we run a pen test on our systems to ensure that our updates, our policies are up to date, and our system is really secure. Like a while ago, we have a shared security model as well. I think you can just look at it later, but the shared security model is pretty much the same for us and Trend Micro. So we also have monitoring and alerts, user access. So this is how we manage our security. We also have instant on security. As we just like what Sasha said, when our instances boot, it automatically gets activated from the master. So it's already protected upon installation. Another thing that I can share is continuous security. Now, some people might be afraid to change config, security policies on the production. So what we do is we have an exact replica of our production in our testing environment. So we also have Trend Micro there. We also have the same setup as we have. This has helped, CloudFormation really helped us with this. So we have the same consistent system. So when we test our policies and the roles in the UAT first. If our testing is okay, we push them to production. So this is one way of mitigating risks in life. So you don't have to be, you don't run into risks like that. And then I have this real life example. One of our servers get a massive spike of traffic. So of course we see it on our monitor, so we check. We check the intrusion prevention of the deep security module. So we check, we can get the IP address of the actual person who did it. And we can track it. You just go geolocation, you can find the location where the attack came from. Maybe a virus, maybe a bot, but we know where it comes from. Okay, so last few slides. Yeah, we save a lot of money and time because instead of trying to set up everything ourselves, it really helped us with AWS and deep security, help us automate a lot of things. We didn't know that attacks are really happening a lot. If you look at our logs, you can see like a lot of people trying to go at us. I'm pretty sure other websites also experience the same thing. And next slide. Building a secure infrastructure can be very challenging in the beginning because if you set up your private VPCs, you will have routing issues. You might not be able to communicate online. You might have issues there. But it's very hard in the beginning, but when you get it right, it's going to be very easy in the end. CloudFormation and OpsWorks and Beanstalk is always your friend. For us, what we do is this platform is brandable. So we sell it, we allow people to use our platform. So for us, we deploy as at least two setups per month. CloudFormation removes the guesswork and the repetitive task for us. So it's also very good to know your limits on the accounts. For example, there's a 30 limit on load balancers or 100 buckets, so you can plan your infrastructure accordingly. Then for my last slide, you see the one on the right, and then you see the one on the left. You can have this kind of level of security and sophistication inside a startup. You don't have to know that you have a DEF CON building or something very complex. You can achieve the same set of security inside a startup with these tools if you do it right. So that ends my talk. Thank you very much.
Thank you, Paul. Greatly appreciated. That's a great example of some joint success between, with MatchMove, AWS, and Trend Micro. Guys, to finish up the session, I know we've gone slightly over time, we're about to get kicked off, but there is one final promotional video that I'd just like to show you. It goes for about 60 seconds from Trend Micro. Before I do that, I'll officially sign off. If you've got any questions around any of the stuff that you've seen, please come and join us at our booth just outside the doors here in the foyer. And I greatly appreciate your time, and thank you so much.
The cloud powers your apps, and your apps are an integral part of your users' lives. They trust their data to you. Be sure you're honoring that trust by securing your cloud deployments.